This is going to be a quick overview of the method of solving quadratics using square roots. So in previous lessons, we have done factoring, and you saw that not every expression was factorable. Sometimes you couldn't do anything. So that means that even though factoring is quick and it's easy, it's not always going to work. So we have to have some other options, and we're going to talk about 3 more options other than factoring. The first one we're going to talk about today is using square roots. This is another one that's really easy, but it doesn't always work. And so when you are able to use square roots is when the squared term can be easily isolated. Here are some good examples to kind of compare here. X squared minus 8x equals 4 is good because I could easily get this term by itself by adding 8 to both sides. The second example is good because the squared term is this whole quantity right here. X plus 1 quantity squared is equal to 15. I could undo this squared here by square rooting on both sides. These 2 examples are not good because there'd be no way to just get the x squared by itself. Here I could add 5 to both sides, but then I'd still have this x left over, which we don't want. Same thing here, I have this 7x. Now something that I've seen a lot of people doing is combining these terms and getting something like 11x squared or 11x cubed. You cannot do that. Like terms have to have the same variable to the same exponent. So that means you can't combine anything that have different powers. So this is what we're looking for today. So something just to think about is when I say that x squared is equal to 16, what is x? And the one that comes to most people's mind is they say, well, x has to equal 4. But is that the only thing that it could be? I know that x could be 4 because 4 squared is equal to 16. But isn't it also true that negative 4 squared would be 16? It is. And so in this equation has 2 possible solutions. I could either plug in positive 4 or negative 4 for x. This is a really important thing. When we are solving using square roots, this is a really important rule. Put this in your notes. Whenever you introduce a radical into an equation, we have to account for both the positive root and the negative root. Now, if I just walked up to you and said, hey, you, what's the square root of 9? You would just say 3. We wouldn't worry about the negative one because that's just the principal root. The square root of 25 is 5. But if I said, what values of x would make x squared equal 25? Well, there's 2 possibilities there. So when you introduce that radical, that square root, that's when we have to account for both of these things. Now, I know that you guys have seen this symbol recently, but we use this plus or minus to represent both of those possibilities. So putting all of this together, this is the method we're going to follow to solve by square roots. Number 1, we're going to isolate the squared term. And like we saw in those first 2 examples, it might just be one variable, like an x squared, or it could be a whole quantity, like x minus 2 quantity squared. Either way, that's the piece we want to get by itself. Then we want to take the square root of both sides, and this is the moment where you introduce the radical. A lot of people will tend to do all of the algebra and then just stick a plus or minus in front of the answer, and that's not correct. That plus or minus has to show up, immediately after you take the square root of both sides. Okay? Then we're going to have a radical, so we want to simplify it. If it works out evenly, then you just go ahead and take the square root. And so then sometimes after that, there's going to be some more algebra that needs to be done. So that's your step 4, is to finish solving if necessary. I would go ahead and put this video on pause for a second so that you can get these steps copied down into your notes. Alright, so here is an example of using square roots to solve an equation. So step 1, again, is to get the squared term by itself. That is going to be x squared in this case. We're going to follow the same steps that we would for any other equation. So my first step is going to be to add 31 to both sides. That gives me 4x squared is equal to 80. And then I need to divide by 4 to get that x squared by itself. So now I have x squared equals 20. My squared term has been isolated. So now is where we want to introduce our radical. We are going to take the square root of both sides. So I have x equals, this is where immediately the plus or minus comes into play. And so we have plus or minus the square root of 20, but remember that what you talked about yesterday, maybe, I don't know, is that the square root of 20 is the square root of 4 times the square root of 5. And since this is a perfect square, we can take the square root of that. So plus or minus 2 root 5 is the simplified version of this. Now, side note, unless it tells you to round, don't. Unless it says round your answer to the nearest blah, 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 you need to assume that we're looking for the exact values, meaning leave it in simplified radical form. And just like with fractions, your radical should always be simplified. It would not be acceptable to leave this as the square root of 20, nor would it be acceptable to put down 4.6, whatever that comes out to be, because it did not tell us to round. So you need to deal in exact values. Let's look at another example. Here's one where we have a squared quantity instead of just a squared variable. So if we look at this, I have 4 times the quantity x minus 1 squared equals 16. Now, these parentheses have a job. They are to square that x minus 1, which means you cannot distribute this 4. Just like when it was absolute value, just like when we were doing the transformations, you are not allowed to distribute that 4. So how do I get rid of it? Well, distributing is multiplication. So if I want to undo multiplication, we use division. And so I get x minus 1 quantity squared equals 4. Here's where this idea of introducing the radical immediately after you square root is going to matter. In order to get rid of this squared, I'm going to take the square root of both sides. On the left-hand side, that just leaves me with x minus 1. And on the right, I get plus or minus 2, because the square root of 4 is 2. Do not forget your plus or minus right there, because this is what I was talking about, where now we have this step 4, where we have an additional step at the end. We have more algebra that needs to be done to get x by itself. So I get x equals 1 plus or minus 2. Notice that I put the number in front of the plus or minus. That's always the way that you want to do it. And since both of these are whole numbers, that means that my two possibilities would be 1 plus 2 or 1 minus 2. 1 and 2 are like terms, so we need to go ahead and simplify it down as much as we can. So x could be 3 or x could be negative 1. And so that's what we get. Make sure you don't distribute. Make sure that that plus or minus gets added in immediately after you take the square root. A lot of people, like I said, will leave the plus or minus off in this step right here, and they'll get 3 and then add the plus or minus on. The answer is not positive 3 or negative 3. It's positive 3 or negative 1. You have to make sure that you use the plus or minus at just the right moment. Okay. I'm going to do a couple more examples. If you feel like you've got the hang of it, then maybe you can skip ahead. But each one of them does something different, so I would keep an eye on it, especially this example here. When we go to solve this, we can get that x squared by itself. So we're going to. I'm going to start by subtracting 1 from both sides. And I get negative 2x squared equals negative 7. And you might be thinking right now, but wait, Ramsey, I can't square root a negative number, which would be almost true. But think about, this is kind of like when we did absolute value. Sometimes you're going to do more work that's going to take care of those negatives. When I divide by negative 2 on both sides, I get x squared equals, now this is a negative divided by a negative, so I get positive 7/2. And this is our moment where we would introduce our radical. Now there's a different issue here with this one. I get x equals plus or minus. Remember that we can split that up to be the square root of 7 over the square root of 2, which is a problem that we talked about the other day. You can't leave a radical in the denominator. So we would multiply by the square root of 2 over the square root of 2. Our final answer would be plus or minus the square root of 14 over 4. Or not 4, 2. Sorry. Remember that what this is going to do is we can multiply these two. That gives us the square root of 14. And when we multiply the other two, we get the square root of 4, which is 2. That's why it rationalizes that way. And so these would be our two answers. If it did come down to something like x squared equals negative 5, you can't square root a negative. So for now, we're just going to say that that has no real solutions. We are going to talk about a way around that in a couple of days. Last example, this one just has a whole bunch of steps. This is kind of the most that they could throw at you here, which is why I wanted to show it to you. So let's go ahead and start. Again, we're trying to isolate the squared term. So I'm going to start by subtracting 8 from both sides. That gives me 2/5 times the quantity x plus 3 squared equals negative 4. To get rid of this fraction, I'm going to multiply by 5 on both sides. These cancel, so now I have 2 times x plus 3 squared equals negative 20. And now I can divide by 2 on both sides. X plus 3 squared equals negative 10. And here's where we're going to run into an issue like I was just talking about. Here we would square root, but this is a problem. So what you would write down is no real solutions. Alright, so that's it. That's all there is to it. This is very straightforward algebra, so I hope this isn't too bad. You have the rest of the hour to work on the assignment. This is due tomorrow.